Joining me now is Dr. Alejandra Magana from Purdue University. Dr. Magana, great to see you today.
Thank you.
Now, you have a workshop coming up that'll present guidelines for deploying modeling and simulation in the classroom. We'll start with the basics here. What is the need for these types of guidelines?
Of course. Well, thank you first for having
It's
me.
my pleasure.
So nowadays, engineering fields, many of them, if not all of them, require for practitioners equipped with skills that can allow them to use computing to solve problems, to design new materials or devices, and even to aid in the process of discovery. So these practices come more relevant and common in the master's and PhD levels, meaning that they are not very well integrated at the undergraduate level. So really the purpose of this workshop is to help faculty to bring modeling, simulation, computation sooner and often into their curriculum.
Tell me a little bit more about the workshop. What will the attendees learn as a result of attending it?
Of course. So this workshop is the result of a 7-year-long collaboration between my dear colleague Michael Falk he's a material scientist at Johns Hopkins University. I'm an education researcher. So we have been working together to bring these practices into the undergraduate curriculum at Johns Hopkins, and this project has been funded through 2 NSF grants. And in the first grant, we were looking at content, which skills we wanted to bring into the classroom, and the second one focused on pedagogy. So we would like to do in this workshop is share of many of the lessons that we have learned through this 7-year-long process.
Now, I understand that there's an interactive exercise during the workshop. What specifically then will the attendees be doing?
Sure. So we are going to guide participants through a design process. We will help them start thinking about their own course, think about specific course objective. They think it could be complemented or even supported by the use of computing. And then we will guide them through, okay, now what is the computational skill you want to integrate, and what is the ability you want to reinforce into your students. Then we will continue with assessment. So once you decide what are the goals, how are you going to make sure you have reached those goals, and at the end we are going to talk about supports and pedagogies that will help students reach the learning.
That sounds great, but I'm sure there are some challenges, so let's talk about that. What challenges are there in incorporating modeling and simulation into the curriculum?
Yes. So first of all, it's hard for students. They have to learn the engineering, they have to learn the math, they have to learn the programming. So that is the biggest challenge, making the connection between physical models, mathematical models, and computational algorithms. But we have been able to see that when students overcome those challenges, they really benefit on their learning. We start to see how they are having aha moments when they look at a simulation. They can make those connections better afterwards. And through this research project, we have been able to identify strategies that can help students through the process, make it more easier for them to go through all the hurdles that they may encounter. So we think students are capable of doing this, and professors, we can try to help them integrate them into their core courses.
Now, speaking to that, how important is it then to develop assessment mechanisms or metrics around curriculum tools?
Right. So actually that is very important. We will start by objectives, which set in a way the targets we want to accomplish. And for that, we need to then think about assessment, how we will know students have reached those goals. So it's not an afterthought like many times happen, like, oh yeah, I will do my exam 1 week before the day of the exam. No, we have to start thinking about from the early beginning, and we have developed several assessment methods, rubrics primarily, and that will also give students a specific guidance of what is expected from them when they have to solve a computational challenge or a problem in general.
What's been the reaction from students when you present them with all of this?
Well, let me tell you, we are working with freshman students.
Yeah.
So it's her first semester, one of their first courses. So of course it's challenging.
Right.
But Michael has received emails from students, saying that they have benefited tremendously in their internships, for example. And also we have gathered data in which students, we see that they are getting more confident as they go through their semesters, they gain confidence in their computing abilities. So, I mean, we have positive results. We are very excited about this project, and we hope to share this with faculty.
It sounds fantastic, Dr. Magana. Thank you for your
Thank
time.
you so
It was
much.
great to meet you.
Thank you.